So here's a look at the plates. Each color block here is a different plate. They are the lithospheric plate, so it includes a crust in the upper mantle, and there are about 20 of them. They move around at a rate of 1 to 15 centimeters per year. I would say the average is probably something close to 3 to 5 centimeters per year. The boundaries in this image are designated by different patterns. So trenches or collision zones are that looks like tiny little hyphens, dashes, and most of those are over here around there's around Australia, up through India, there's some here around the Philippine plate, up around the northern part of the Pacific. Well, it skips a little bit here, but we go over to the edge of the Nazca plate where it is subducting under the South American plate. So those are all collision zones where plates are moving together. Ridges are in the middle of our ocean basins. So there is a ridge here in the southern Pacific Ocean. It keeps going all the way across. And then in the Atlantic, all the way up the middle of the Atlantic Ocean is a mid-ocean ridge. Transform boundaries, there's only a few that are plate boundaries. So the transform plate boundary over here in California, known as the San Andreas Fault System, that's a transform plate boundary. There's also transform motion at the northern edge of the Caribbean plate. Transform boundaries, then for plate-wide boundaries, there's fewer of those. Transform faults, though, do make those little notches in the mid-ocean ridges known as fracture zones. So here's a really big one here. There's a fracture zone across the mid-ocean ridge. So each of these stair steps are little fracture zones that are tiny little transform boundaries. So here we've taken that plate and kind of plate map and kind of expanded it so you can see the shape of the individual plates. The North American plate there across the top is big. Okay. The plate boundaries are where most of our earthquakes and volcanoes are. So this is an earthquake map. The earthquakes, if we were to connect the dots, we could just dot, 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 all these little dots, and we would figure out the plate boundaries. So notice that they really are, most of them are in these convergent zones with the convergent plate boundaries. But there are also earthquakes along the mid-ocean ridges. Okay, continental margins. The edges of our continents are either going to be classified as active margins or passive margins. An active continental margin is going to be one where there is a plate boundary. So mostly those convergent plate boundaries at the edges of continents, active plate boundary. Passive margins are like the image here, where it's not at a plate boundary. At a passive margin, you will find a broad continental shelf. Underlain by, these are fault blocks. This is faulted continental crust where the plates were together and they have, over time, a spreading center formed and the plates have drifted apart. So that right when they started to drift apart, there was some rifting and faulting, and those ancient faults are here, these fault blocks. So that's what you would find if you could look down into the edge of North Carolina underneath our continental margin or underneath our broad continental shelf. You would find a bunch of bedrock that is faulted in this way. There are faults like that that come up into the North Carolina, into the land around Raleigh and Durham and Chapel Hill, where there's big valleys, and maybe up the hill to go to Chapel Hill. Those are the Triassic basins from the rifting of the Atlantic Ocean. Okay, so this is a passive margin, a broad continental shelf. It leads right into the oceanic crust. There's no volcanoes, no earthquakes, just a quiet passive margin.